All right, welcome back. Today we're going to talk about section 6.2, which is arcs and chords. A couple new vocab words today. Let's start off with our first two. A central angle is an angle whose vertex is the center of a circle. So there are infinitely many of these. You should take a look at our circle down there. That's an angle. The vertex is the center. That's a central angle. Okay, or we can draw one that looks like this. Or one that looks like this, or one that looks like this. Those are all central angles because the vertex is always the center. An arc is an unbroken part of the circle consisting of 2 points called the endpoints and all the points on the circle between them. Okay, so let's draw a central angle here. So here's my example central angle. And let's name these points A. I'm going to call the center O, and let's call this point B. I'm going to put another random point somewhere over here. We'll call that point C. Okay, this is called an arc. This is also called an arc. There are different kinds of arcs. We'll get into that in the next slide here, but those are both called arcs. It's an unbroken part of the circle consisting of 2 points called the endpoints and all the points between them. So let's focus on the green one here. The green one, I would call this one arc AB. Okay, arc AB. So how do we write that? We put an AB, and then remember back in the first semester we had a lot of hats that we would give these 2 points. There's a new hat, it's an arc hat, and it looks like that. So this is read as arc AB. Okay. The orange one is not called arc AB. We'll talk about what that's called now, but we'll say why in the next slide. We would actually call this one arc ACB. So you'd write ACB with an arc on top of it. So why the 2 different names? Well, we couldn't call them both the same, otherwise you wouldn't know which one they're talking about. All right, so how do we know which one is to say with 2 letters, which one we say with 3 letters? You might be able to tell just by looking at it already, but if not, let's take a look at the next slide. There are 3 different types of arcs. The first one is called a minor arc. A minor arc is an arc whose points are on the interior of a central angle. Okay, the measure of a minor arc is equal to the measure of the central angle. So a minor arc is always less than a semicircle. Okay, what's a semicircle? A semicircle, if you go down to the third one there, is basically half a circle. Okay, so let's skip the second one for now. Let's go to the third one. If the endpoints of an arc lie on the diameter, that arc is a semicircle. So let's go back up here. If we were to fake draw in a diameter here, there's a diameter. Clearly the green one is less than that diameter. So the green one is less than a semicircle. That's why we would only name that a minor arc, and we'd only use 2 points to name it. The orange one is clearly bigger than the semicircle. So that one is called a major arc. A major arc is an arc whose points are on the exterior of a central angle. Okay, so the orange one's called a major arc, and for that one we use 3 letters. So we still use A and B as the endpoints, but then we have to make up another point somewhere in between there, or use a point that's given to us on the circle in between to show that it's major. So minor arc, 2 letters, major arc, 3 letters. How about a semicircle? A semicircle, you would also use 3 letters. Why? Because you need to know which way to go. What does that mean? Let's put another point in this, call it H. If I said EG, you wouldn't know if you want to go this way or this way. Okay, so now if I said EFG, now I know it's this one. Or if I said EHG, I know it's this one. So semicircle, you also need 3 points to use. And that's just a summary down here. Minor arcs can be named by 2 points. Major arcs and semicircles must be named by 3. Next vocabulary word is adjacent arcs. Now we kind of already know what adjacent means. Adjacent means next to. So adjacent arcs are arcs of the same circle that intersect at one point. In other words, they're right next to each other. So in this picture here, the red and blue arcs are right next to each other. So those are called adjacent arcs. So you would say arc RS and arc ST are adjacent arcs. And building off of that, we have the arc addition postulate, which says we can add two arcs together, two small arcs together to get a big arc. Okay, so building off of this, what we just did here, we could say arc RS, so the measure of arc RS, plus the measure of arc ST must equal the measure of the big arc, RT. So small arc plus small arc equals big arc. Okay, and just like congruent meant in the first semester, congruent still means here the same. So if two arcs have the exact same measure, those arcs are called congruent. Just like congruent segments, just like congruent angles. So here we have a question that says, find the measure of arc BD. So first thing I'm going to do is I'm going to trace arc BD so I know what I'm looking for. There's arc BD. All right, so a couple things that we need to make sure we remember in order to do this. We have to know that a circle's arcs always add up to 360 degrees. So all the way around here must add up to 360 degrees, okay? Which means a half circle, a semicircle, would be 180 degrees. Okay, we also must remember what we just learned a couple slides ago here that says a minor arc is equal to its central angle. So in this picture here, if this angle is 97.4, this arc is 97.4. If this angle is 52, this arc is 52. Okay, now we can do a lot of other math figuring to figure out the rest of this. Now we also learned in first semester, in chapter 2, I believe, about vertical angles. Remember, vertical angles are angles that look exactly across from each other if you can see an X in the picture. So there's our X formed by AC and BE. Those two angles are directly across from each other. Those are called vertical angles. So that means this angle must be 97.4 and this arc must be 97.4. Okay, so last thing we got to do is get these other two arcs that are here. AB is not necessary, but let's find it anyway. To get AB, what you want to do is you want to say, all right, I know this is a diameter, so I know this is 180. So if I do 180 minus 97.4, I would get the measure of that other arc. And that would be 82.6. 82.6. So then finally, to get arc CD. All right, so using my vertical angles again, I know this whole thing is 82.6. So if I can do 82.6 minus 52, I know this angle in here would be 30.6. So this arc would be 30.6. Now I know every angle and arc in the picture. I can finally answer the question. The question says, what is the measure of arc BD? So from here to here, I simply add 97.4 to 30.6, and I get measure of arc BD is 128 degrees. Let's take a look at example 2. Example 2 says to find LJN. So immediately you know LJN is a major arc. LJN. So that is the arc we are looking for from here to here. Now this is a much easier one. There's a couple different ways to do this, but there's a really simple way to do this. So let's do it that way. I know this angle here is 40, which means this arc is 40. I know this angle here is 25, which means this arc is 25. So this purple arc here is 40 plus 25, 65 degrees. All right, once again, we know a full circle must be 360. So if the whole thing is 360 and the purple one is 65, all we gotta do is 360 minus 65. And that would give us the measure of arc LJN to be 295. All right, now we have a theorem that says in a circle, if a radius or diameter is perpendicular to a chord, it bisects the chord and the arc. Okay, so you see a little picture that says CD and EF are perpendicular, therefore CD bisects the arc and chord EF. All right, why is that helpful? Let's take a look at example 3. It says find the measure of NP. So we're looking at this, we're trying to find that segment right there. Okay, ignore that for now. What we need to do is we need to draw a right triangle in somewhere. So you have two options here. You can either draw a segment from Rn or from R to P. I'm going to do from R to P. And that is called a radius. Obviously, we know that, right? Okay, so we got that right angle symbol there, which means all these angles are right angles. But more importantly, that we're going to use this angle right here as a right angle. We know this is 8 plus 9, which is 17. So Rm is 17. Rm is a radius, which means all other radii are also 17. Why is that important? Because Rp is a radius, which means Rp is 17. Okay? And then we have Rs right here is 8. So this is 8. And we don't know Sp. So I'm going to put a variable on Sp. I'll call it x. And because it's a right triangle, we can do Pythagorean theorem. So we have 8 squared plus x squared equals 17 squared. And if we do the Pythagorean theorem correctly with our algebra there, we should get x is 15. Okay. Now we can use that theorem that we just said. It said if the radius is perpendicular to the chord, it bisects the chord. So what does that tell us? That tells us that if this is 15, this is 15. So therefore NP must be 15 plus 15, or 30. All right, example 4, pretty much the same thing, just practice with that. So let's draw in PQ this time. I know PS, which is a radius, is 10 plus 10, which is 20. So PQ is also 20, because they're both radii. I know PT is 10. I don't know TQ, so I'll call that X. And then once again, we could do Pythagorean theorem. X is equal to the square root of 300. If you want to keep your answer exact, we can do x equals 10 root 3. Or if you want to just put it in a calculator, you can do that as well. Maybe x is approximately 17.321. Okay, but remember, we're not trying to find x, we're trying to find QR. But I know all we have to do is double what we got for x. So we can say x is equal to 2 times 10 root 3, which is 20 root 3. Or if you just want to double the rounded answer, 34.641. All right, before we take a look at the extra practice, there's one more problem I want to do with you, and then I can have you try the last 3 on your own. Let's take a look at the extra practice number 2. So number 2, it says in circle O, the measure of arc ACB is 200. So ACB is 200. So 360 minus 200 is 160, which means arc AB is 160. Which means angle O is 160. Okay, then also remember, because AO and BO are radii of the circle, they're congruent, which means this triangle is isosceles. And we are looking to find ABO, so this angle right here. But since the triangle is isosceles, that means this angle is the same as that angle. So now I can say, all right, 160 plus x must equal 180 because every triangle's angles must add up to 180. Now I get 2x equals 20. So x is 10. So the measure of angle ABO is 10. At this point, go ahead and pause the video, and I'd like you to try the extra practice 1, 3, and 4. And when you're done, you can unpause and check your answers. There's your answers for problems 1, 3, and 4. That's it for section 6.2. We'll be back with section 6.3 tomorrow.